Hi all, and welcome to this discussion where we are going to talk about the process of how to assess the software architecture for performance and scalability. So, what we are going to discuss today is basically we'll talk about a process, assessment process for performance and scalability, and we'll divide that process into number of steps, and then we'll talk about each of those. So, we'll talk about the scope of the assessment, and then we will list down the activities which needs to be carried out during such assessment. Then we'll talk about the ownership of different activities and the list of deliverables which you will be delivering after the assessment. And then we will also talk about some of the critical architecture parameters which should be assessed as a part of this process of assessment of architecture for performance and scalabilities. So let's get going. So the assessment process, when you begin with the assessment process, the most important thing to begin with is to finalize the scope. The scope should be clear and well defined. What exactly you are going to assess, what are the components, what would be the boundaries you would be accessing, and all those things. So make sure that the scope is clear and well defined. And because this is a assessment for performance and scalability, so make sure that you communicate with all the stakeholders that you are going to focus only on the performance and scalability aspects. This is not a detailed design or code review process, or it won't cover extensibility, operations, deployments, security, and all those other quality attributes of the architecture. You are going to focus only on the performance and scalability, so you have to make it clear and well defined. And apart from application architecture, you will also establish that the scope would include the detailed low level design review of three most critical use cases, and focusing only on the performance and scalability for those three critical use cases. So 3 is a generic number, depending upon the complexity of your system, the application you are assessing, you may choose more, but generally 3 would be a good number to begin with. And make sure whatever scope and activities you list down, it is communicated and agreed. So once you have defined the scope, next you have to list down the activities which needs to be carried out during the assessment. So let's talk about that. So the list of activities generally which is part of such assessment is, initially you would start with the high level architecture discussion, so that you can understand what are the overall architecture, what are the technical components. So it need not to be a drill down detailed discussion, but it should be good enough starting point for you to begin having more detailed discussions later in the process. Next, once you have understood the architecture at high level, you need to working with the project team or application team, you need to understand and identify the three most critical use cases, which is very critical for the success of the application. So you need to identify those with the help of application team, or maybe business, the client, and then the scenarios of those use cases, and then the NFRs for those use cases. So if you identify say use case, fund transfer is very important, I'm just taking an example, then you need to understand the scenarios. For example, fund transfer is a use case, it has scenarios like enough balance, not enough balance, and all those things. So you may not need to focus on all the scenarios, just the critical scenarios in that use case, and then the NFRs around that use case. How many people would be doing the concurrent fund transfers, what would be the failure rate, what is the expected response time, and all those things. So you need to identify all this. Once you have identified the use cases also, then you go and start having a detailed discussion about the architecture, low level discussions about the architecture, the flows, the integrations, the critical architecture and design decisions which have been taken. So all those discussions will come. You need a good interaction with the application architect, application team at this point of time, along with the documentation also. So it is not a standalone activity which, as a architect, you would, as a performance architect, you would be doing standalone. It has to be very interactive. with the project team, with the application architect especially. And then you will also have a design discussions on each of the identified use cases. It will be low level, step by step discussion around each of the step which is executed as part of that use case. So once you understood the detailed architecture, the low level design of all those use case, you should have understanding about what are the potential bottlenecks from performance and scalability point of view. Then you will start preparing the assessment report based on your discussions and going through the documentation and all those stuff. And then you will when you prepare assessment report, you will suggest what are the architecture or design alternatives which should be taken care of, what are the potential bottlenecks. And then you will also identify of next steps, how to take it forward. Is some POC required? Do they need to? So after you have identified all the activities, you need to define the ownership for all of those activities. Here you can see a sample ownership or Raki matrix basically. So I'm assuming that you are doing a role of performance architect here. You are there as a performance architect to do the overall assessment. So this is what your role is. If you are the architect who is assessing his own application, then this Raki matrix might change a little bit. This ownership matrix might change a little bit. But important point is that if you are a performance architect and you are doing a high level architecture discussion, then you need a close interaction with application architect. This interaction is very much required. You can refer to documentation also, but most of the time it happens that documentation doesn't capture all those design decisions, architecture decisions and all those things. So if you see, most of the responsibility and accountability lie with performance architect and application architects. For some of the use case discussions, you may need to get in touch with individual tech leads also. So all this will all these three activities highlights that you need a close interaction. So that's the crux of this. And this ownership matrix needs to be shared with everybody, so everybody knows that it's not a standalone activity which you can carry out. You need cooperation and close interaction with all the application stakeholders. And then you start preparing assessment report, then you will present it, and then there will be normal status tracking by the project management team also. So this ownership matrix will help you in identifying the person. So once you have also identified the ownership, you need to have a list of deliverables which you will be delivering at the end of your assessment. So you will have an assessment report which will have suggested improvements in architecture. So you will say that this is the potential bottleneck, and to avoid this bottleneck, these are the suggested improvements, these are the design alternatives, and how to take these to forward. That next step will also be part of your assessment report. So now after having discussed the overall process, we'll talk about some of the critical architecture parameters which you should be assessing for the architecture, whether your architecture, the application architecture, meets those meets those quality attributes or not. So let's talk about those now. So before we go and discuss those parameters, couple of points when you are assessing the architecture. So, software architecture are neither intrinsically good nor bad. They can only be evaluated with respect to the needs and the goals of the organizations that use them. Okay, so any architecture as a standalone entity is not good or bad, right? For example, for a particular application, choose an architecture can be excellent choice, but same architecture for another application may not be a good idea, right? For example, let's these days NoSQL etc. very popular. If you're for handling all those huge amount of data in big data world, but NoSQL is not a good choice if you have a OLTP application, right? So I'm just taking an example. So same way, you need to understand the needs and goals to which that particular application is catering to. So some of the goals can be the non-functional requirements. For example, your system should be able to handle this much response throughput or response time, all those things. So you need to understand the needs and the goals of the organization to which that particular application is catering to. Against those only you can assess the application. So another good point is in one of the research paper is whether or not a system will be able to exhibit its desired quality attributes is largely determined by the time the architecture is chosen. So once you choose the architecture based on some of the architecture decisions, at that point most of the uh, quality attributes, whether your application will meet those or not, the non-functional requirements, it can be generally judged by the architecture decisions itself. So keep this in mind. If you choose a wrong architecture later, in later stages of your software development life cycle, it may be very late to correct something because the architecture decisions you made might not be correct. So keep that in mind when you're designing. So the first important quality attribute would be the resource and connection pooling. So before we begin, whatever parameters or quality attributes we are going to discuss, it's not in any specific order. Depending upon your application, the order might change. For example, some of the application might have resource or connection pooling as a top priority, but for some other it might not. It need not to be that important. So keep that in mind while we are discussing these attributes in next few slides. So it is important to reuse the resources which are expensive in terms of resource consumption or time needed to create new connections or new resources. So always try to reuse those. Make sure that your architecture and your design promotes this reuse. For example, DB connection pools, connections for remote communication, etc. Such examples. And also keep an eye how long resources are held. For example, if these are expensive resources, make sure that you release it as soon as possible instead of waiting for complete use case to be executed, complete transaction to be executed. Make sure those are freed as early as possible. And then another important point would be the throttling. Throttling is an important point. There are resources. For example, even if your web server is handling 1,000 concurrent connections, your DB should be throttled to a lower number, right? Number of connections to DB should be at lower end. So that kind of thing should be there in your architecture, in your design. Caching is another one of the most critical aspects. Consider caching across layers. It can be UI, app layer, service layer, DB, OS, etc. Then there are facilities like CDNs and distributed caching products and frameworks. So if your application needs those, uh, use these facilities available. CDNs and distributed caching can improve performance by order of magnitude. And don't just rely on framework specific caches. For example, Hibernate is one such persistent framework where it has its own cache, but sometimes we have seen that it's not that useful. You might need to you might need to use some other caching. So even if you are using framework caching, or for that matter any caching products or facilities, make sure you always measure the cache utilizations, etc., and see what is the best possible caching strategy. So simply by using one of those distributed caching products, etc., or maybe even CDN, you have to see the utilization, how your cache is effectively being utilized, so that you know whether it's working or not. Concurrency is another parameter which should be assessed. For example, your design should not be you should not have a design which prohibits concurrency. It will have performance and scalability impacts. For example, if you are creating threads on demand for every request instead of connection pool, then on higher scale you might run into some kind of issues. Make sure you are using synchronizations and isolation level to the at an appropriate level. You should not be synchronizing a big method or big piece of code. Same way, isolation levels for transactions should be appropriate. uh, you should be aware that choosing what kind of isolation level will have impact on performance. So you should need to look at your databases or middleware, whatever you are using, to understand how isolation level works in those. Log granularity, again, if you are locking the complete database table, I'm just taking an example from database point of view, then it may not be a good choice. You need to understand how you can lower down the log granularity. Asynchronous call, using asynchronous methodology or approach can be another way to handle larger concurrencies. Attribute asynchronous, as we touched upon in the last point also, this is one of the most critical aspects from scalability point of view. It decouples your backend resources from load coming into a system. For example, if you have a large amount of load, maybe thousands and thousands of concurrent requests coming into the system, and if your business case permits that, if your use case design permits that kind of, you take those incoming requests, put it into some kind of message oriented middleware MOM like JMS or Kafka or web server MQ, then even though your system web server is handling thousands and thousands of concurrent requests, your backend servers like app server or your DB server need not to scale to those kind of levels, right? So asynchronous can help you achieve better scalability in longer run, and you can have some kind of callbacks, etc., to see, if you actually need to see the results of those asynchronous calls. If it's just a fire and forget use case, then you even don't need to do that. But if you need to look at the results, then you can use callbacks, etc. Coupling and cohesion is another design attribute which you should be assessing. High coupling between layers can result in scalability issues. So if there are layers which are tightly coupled, if you have to scale something, you need to scale everything, right? It will not give you good freedom. Heavy session states, etc., should be avoided. So session state is here it is a, you have to maintain a balance between performance and scalability. The more data you put into the session or state, you will have better performance, because it will avoid round trips and calls to database or external systems. But then you will run into the scalability issue, so you have to manage it properly. Don't make it too high just to achieve better performance, because if there is a if you need better scalability, then heavy sessions might give you problem. And then excessive calls, chatty application is a sign of possible low cohesion. And if you have excessive call or chatty applications, it means you might run into performance issues in your application. So these are the points you should be considering. Then communication with the external systems and all those things needs to be looked into. Avoid unnecessary round trips. See if there is a possibility of batching the requests, and always consider the protocol which is being used and its overheads. For example, if I take example of HTTP versus HTTPS, generally HTTPS will have at least 10% overhead. So that kind, even if you are using complex protocols and all those things, you need to be aware of the overheads and its demands. And transfer only the required data instead of passing the complete data. Transfer only whatever is required. Have a look at the data formats also. JSON, XML, object. There are n number of different formats which you can support. Each will have its own implication. For example, if you are passing an object, say Java object, it will be of very less size as compared to XML, and JSON will be very huge. So keep an eye on that, whatever format you are choosing. And if possible, always try to compress the data which is which you are transferring, so it will save huge network latency time. Then have a look at all the technical components used in the your application. Some of the products like cores, etc., may have its own performance bottlenecks, known performance issues, especially with today world in open source software. Some of them might have some performance issues, known performance issues. So keep an eye on those, whatever components are being used. And if it's cores, etc., you have to analyze. Most of the vendor provide their own benchmarks, so you have to analyze those, whether it will meet your requirements or not. Then session management, we talked about it, in previous slide. Session management prefer stateless components as much as possible, or keep session as light as possible. For favoring heavyweight sessions might give you performance benefits, but can impact scalability. We talked about that in previous slide also. Depending on session size as well as availability requirements, session state might need to be persisted or replicated. This will have its own performance impact. For example, if your application is running in a cluster and it's an online banking transaction, you cannot afford to, if one of your application server instance goes down, you cannot afford to lose that transaction. For that, your transaction need to continue at the on the second server instance. For that, your session needs to be, taken out from the process memory of the server, individual server, and put into the some kind of shared place. It may be database, it may be some kind of messaging queues, it can be anything. But point is that it will have its own performance bottlenecks, or implications, basically not bottlenecks, implications. So keep that in mind. If your session is replicated on a common shared space, it will have its own performance implications. Keep that in mind. Then the deployment architecture, avoid unnecessary distributed layers. The more layers you would put, it will need more round trips, more communication. And components which need to communicate more frequently, place them as close to each other. And for example, if your service layer is in a J2E EJB, then session bean and entity bean which is representing your model, or data classes, those should be some kind of, in the same JVM will have least latency or least overhead. So you have to look closely how you are actually deploying your artifacts onto the infrastructure. And always see, if there is any design decisions which has been taken which can prevent load balancing or scaling out. For example, you have implemented a piece of your design which runs only on one of the server. Not even if you scale your applications to tens of instances, tens of cluster members, if your design is such that that particular piece runs only on one server, you will not be able to scale, because your design is such that that critical piece cannot run on two servers. So you have to keep that in mind if there is any such decisions. And if it's an existing infrastructure, existing application you are assessing, always see what are the resource utilizations, memory, CPU, network, disk, etc., to see possible bottlenecks. And then always keep an eye on some kind of, most of the system will have some kind of bulk or schedule jobs or reporting requirements. These can have, performance implications, because when your schedule jobs or some kind of data pooling for report happens, it can, impact the online flows of your applications, and it can have huge impact on resource requirements and performance for online or critical flows. See if those can be executed during off-peak business hours, so that it doesn't clash with your online flows. So that is another point you should be looking into. And then make sure the system, application has some kind of system management and monitoring tool. For any mission critical system, it is imperative to have a good system management or monitoring tool. For example, there are Tivoli and Dynatrace, Luxit, etc., etc. Those kind of OEPM tools are available, which not only let you monitor and debug current performance of the system, but it also stores historical data, so that you can do drill down RCA if there was any issue. You can do all those things. It will give you, these kind of APMs will give you layer wise breakdown of transaction time, so that you can exactly see which is the potential bottleneck in your system. So these were the some of the points you should be assessing against. So if you have any question, any query about the overall assessment process we talked about earlier, or these are the quality attributes or parameters against which you should be assessing, just leave a comment and I'll get back to you on this. Thank you very much for your time.